Hi all, welcome to Sahara IAS. Today in this class, we will be seeing the topic that is ratios. In this session, we will be seeing some introduction concepts that are related to ratios. First point, let us try to understand how to use ratios and what is the purpose of ratios. The purpose of ratios is to compare two or more quantities. And how to compare? We can't compare them quantitatively, but we can compare them qualitatively. If we attach a number to the quantities or for the entities, then we can compare them. But qualitative comparison is not possible using the ratios. For example, I can't compare green and blue. So this comparison is not possible, but I can compare a person with 28 kgs and a person with 32 kgs. This is possible because this is quantitative comparison or qualitative comparison. Quality means something which defines the quality of an entity. Quantity means which assigns a number to it. So this is a quantitative comparison and not qualitative comparison. So this can be done, this comparison can be done using the ratios, but not this one. Now, if I consider ratios like this, A is to B is equal to 2 is to 3. This can be also written as A by B is equal to 2 by 3. And whereas A is to B is to C is equal to 2 is to 3 is to 4. This cannot be expressed in the form of a fraction. This is a direct ratio, and the difference between fraction and ratio is this: the fraction can compare two entities, but the ratio can compare two entities or even more than two entities, and it can compare any number of entities like A is to B is to C is to D is to E is to F. We can compare any number of entities using the ratios, but the main point here is they should be similar entities. A and B should be similar entities. But what if I consider like this: 28 kgs, 32 kgs and 38 kgs. This can be compared, all the three can be compared here. But if I say 28 kgs and second one if I say 3 meters, now I can't compare this because these are dissimilar entities. We can't compare dissimilar entities in the ratios. We can compare only the similar entities. Next, suppose if I randomly give you 10 and 100 and ask you which is greater, we will obviously say 10 is greater than 100. And if I say like this 10 and 100, but now I will attach a dimension to it, like let's consider this 10 as meters and 100 as centimeters. Now obviously 10 meter is more than 100 centimeters. So before comparison, we should make sure that the unit of comparison should also be same. So if this is in meter, this should also be in meters, only then we can compare. Or if this is in centimeter, this also we should convert it into centimeter and then we can compare. So unit should be same before comparing in the ratios. Third point, if I consider like this: A is to B is equal to 2 is to 3 and C is to D is equal to 4 is to 5. Now I can say A by B is equal to 2 by 3. I can write like this. Similarly, C by D is equal to 4 by 5. This is also correct. Now I cannot write A is equal to 2 and B is equal to 3. This is wrong. So what we need to do is we should consider a common variable, that is A is equal to 2x and B is equal to 3x. We should not directly take A is equal to 2 and B is equal to 3. Similarly here, C is equal to 4, D is equal to 5 is wrong. Then C is equal to 4x, D is equal to 5x is also wrong here, because when we are using x as a variable for one ratio, we can't use the same variable for the other ratio. This is not allowed. So this is also wrong. So what we are supposed to do, we should use a different variable here, that is C is equal to 4y and D is equal to 5y. Now it is correct. So this is how we will be comparing the entities, and this is same for even if more than two entities are there, then also this is correct, like A is to B is to C is equal to 2 is to 3 is to 4. Then I can say A is equal to 2x, B is equal to 3x and C is equal to 4x. There is no problem in this. We can compare any number of entities using the ratios. Second point, suppose if this is given: half of A is equal to let's say 1/3 of B, something like this is given. Now to find the ratios, what can be taken is I can take B to this side and send 2 to this side. I will get A by B is equal to 2 by 3. So I can express this in the ratio format as A is to B is equal to 2 is to 3. But what to do when there are three entities, like A by 2 is equal to B by 3 is equal to C by 4? Now to get A is to B is to C value, we need to consider a constant variable k here. Then A by 2 is equal to k, then B by 3 is equal to k, C by 4 is equal to k. Now take 2 to the other side, I can write this as A is equal to 2k, B is equal to 3k and C is equal to 4k. Now A is to B is to C is equal to 2k is to 3k is to 4k. As k is a constant here, I can directly cancel k and I can get the value as 2 is to 3 is to 4. And if we observe, whatever was there in the denominator, same ratio I am getting for A is to B is to C. Next point, if I consider A, 2A is equal to 3B is equal to 4C. Now same thing, equate it to some k, I will get 2A is equal to k, 3B is equal to k, 4C is equal to k. Then A will be equal to k by 2, then B will be equal to k by 3 and C will be equal to k by 4. So this is how we can get the A, B and C in terms of k. Then we can find A is to B is to C value, that is k by 2 is to k by 3 is to k by 2 is to k by 3 is to k by 4. But here the problem is, I can cancel k, no doubt, then I will get this as 1 by 2 is to 1 by 3 is to 1 by 2, 1 by 4. This is the correct ratio, no doubt, but the problem here is we are having the fractions. Generally, we don't prefer fractions in the ratios. So to get rid of the fractions, what we need to do is, we need to take the LCM of all the three numbers, 2, 3 and 4, which is 12 in this case. So we will multiply entire ratio by 12. So into 12 into 12 into 12. Now we will get 2 ones are 2 6 are, then 3 ones are 3 4s are, again 4 ones are 4 3s are. So final value, if 2A is equal to 3B is equal to 4C is equal, all these three are equal, then I can write A is to B is to C is equal to 6 is to 4 is to 3. But this is the basic method. Now if I see the short trick to find A is to B is to C value, A is to B is to C is equal to find A's ratio, what you need to do is you need to multiply these two numbers. That is, you leave the number that is with A and multiply other two numbers. 3 4s are 12. Similarly, to find the ratio in terms of B, what we need to do is we need to leave this number that is with B and I need to multiply these two numbers, that is 2 and 4. 2 and 4 is 8. Similarly, to find the C, leave the number that is with C and multiply the number with A and B, that is 6. Now 12, 8 and 6, it is same as 6, 4 and 3. I can cancel 2 throughout and I can write it as 6 is to 4 is to 3. As we know that ratio should always be in the simplest form. We should not leave the ratio as 12 is to 8 is to 6. It should be simplified further until it is reduced to the simplest form. So this is the second method of finding the ratios. Then third is how to merge the ratios. Suppose if I say suppose if I consider A is to B is equal to 2 is to 3 and B is to C is equal to 3 is to 4. But I want to merge the ratios like A is to B is to C, and I will get, see, if we observe here, B is common in these two ratios and it is already equal in the ratios. In such cases, you can directly merge the ratios as 2 is to 3 is to 4. But what if they are not equal? Like A is to B is equal to 2 is to 3, then B is to C is equal to, let's say, 4 is to 5. In this case, the common entity is B, no doubt, but that B is not same here. To make it same, to merge the ratios like A is to B is to C, first we need to merge these ratios and we need to make the B common, then only we can merge the ratios. So how to make this B entity common or same in both the case? This 3 we need to multiply it to the second ratio. This 4 we need to multiply it to the first ratio. By doing so, let's see what happens. Now A is to B will be 8 is to 12 and here B is to C will be 12 is to 15. Now if we observe, this quantity that is B is common. Common is B and it is already equal now. So now I can merge the ratio as A is to B is to C is equal to 8 is to 12 is to 15. So when the common entity is already having the equal values in both the ratio, we can directly merge the ratios. But if the common entity B is not having the equal value in the ratios, then first we need to make the values equal, then only we can merge the ratios. But we do have some other method to merge this type of ratios. The other method of doing it is A is to B is to C. We have A is to B is equal to 2 is to 3 and B is to C is 4 is to 5. Now what can be done is, first let us mark the blank. Here we have a blank, here also we have a blank. Now we need to fill the nearest number to the blank. Like here for this blank the nearest number is 3, so we will fill same 3 number here. Similarly for this blank we have 4 as the nearest number, we will be filling 4 here. Now if we multiply these two numbers, 2 4s are 8, 3 4s are 12 and 5 3s are 15, we will be getting the same answer, A is to B is to C. So this is the basic method, and whatever we saw now is the advanced method of merging the two ratios. And we do have one more method, that is called as inverted n method. We all know that in English alphabet n is written like this. So if we invert this, this is inverted n. So there is a inverted n method to merge the ratios, that is A is to B is equal to 2 is to 3, B is to C is equal to 4 is to 5. Now B and B, they are diagonally present, then I can directly write a inverted n here like this. Now what I need to do, following the line, I need to multiply two numbers. 2 4s are 8, then 4 3s are, I need to follow this line next. So 4 3s are 12, then I need to follow this line, 3 5s are 15. So hence I am getting the same answer in this case as well. But this is possible only when B and B are diagonally opposite. Then only you can apply the inverted n method. Suppose if the condition is A is to B is equal to 2 is to 3, then C is to B is equal to 4 is to 5. Now the B is not diagonally present, so I can't apply this inverted n method. So one more thing what can be done here is A is to B, let us write as it is, that is 2 is to 3, but instead of writing C is to B as 4 is to 5, we can write it as B is to C as 5 is to 4. Now as we see, this both B and B are diagonally present. Now I can modify the ratio as C is to B is equal to 4 is to 5, as B is to C is equal to 5 is to 4. Now we can merge the ratios, we will be getting 10 is to 15 is to 12. So these are the different methods of merging the ratios. Most of the questions in ratios, two ratios will be given. Before comparing any two entities, we need to merge the ratio and then we can compare. So this we will be seeing how we can implement this type of merging the ratios concept in the problems. So this is all for this session. Thank you. So